Okay, so 2.4 is going to cover given two functions, f and g, find their sum, their difference, their product, and their quotient. And for a pair of function f and g, find their sum, determine the domain of their sum, the difference in the product, and the quotient. Okay, so we've got some basic things that we can compare down here. And so these are really just definitions. So if you have this, it really means you can separate them out and add them. Same thing with the subtraction. The multiplication, you can list them out separate, and the division. Okay, and we already talked about the fact that in the denominator that you can't divide by 0 or you'll get an error. Okay, so in our example over here, we've got the function f of x is equal to 2x minus x squared, and g of x is equal to 3x plus 1. And it wants us to find the following. So if we're adding these, f of x would be 2x minus x squared. I'm getting that from right here. And g of x, adding it on, we don't have to, adding something doesn't change the sign, so we don't need to put it in parentheses or anything. But we would get this. Okay, so we're adding our f of x and to our g of x. In fact, let's just go ahead and make that g of x green. So, sorry, g of x is green. And let's leave our f of x blue. So, you can kind of clearly see that we've got 2x minus x squared plus 3x plus 1. Well, we can combine like terms, but that's about it. So when I'm looking at this, the highest power of x I see is my negative x squared. So most of the time you would list that in the front. Okay, and then I would combine my regular x's. I've got a 2x plus a 3x. That's going to give me 5x. And we've got a plus 1 at the end. Okay, so when we subtract these, you want to make sure you use your parentheses this time. So f of x is going to be 2x minus x squared. We're getting that from right here. And then minus g of x. And we're putting that in parentheses because we want to subtract the whole thing. And this time when you subtract, it does change the sign. So g of x is 3x plus 1. So we need to make sure that when we're working the problem, especially for subtraction, that we put it in parentheses so that we can distribute that negative to both things. If we had to put it in parentheses over here, it would have still been fine. It's just that whenever it's a plus, you don't have to do that. So we've got 2x minus x squared, and then we've got a negative 3x, and then we're distributing the negative to the positive 1 over here, so we're going to get negative 1. So the highest power of x I've got is negative x squared. Took care of that. I can combine my 2x minus 3x. That's going to be negative 1x. And then I've got minus 1 on the end. So keep in mind that's the same thing as you don't have to put the 1 in front of the x. You can leave it off. Those would be the same. When we're multiplying these, we've got f of x, which we said was 2x minus x squared. And we've got g of x, which is 3x plus 1. And when you multiply these, you use something called FOIL. So first, outer, inner, last. Multiply the first terms, 2x times 3x, we're going to get 2 times 3, which is 6x, times x would give us x squared. So there's our first terms. Our outer terms would be the 2x multiplied by the 1. Well, 2x times 1 is just a positive 2x. Inner terms would be these two inside. Negative x squared times 3x is going to be negative 3 x to the third because we've got an x squared times x to the first, so that's going to be x to the third. And then our last terms, negative x squared times 1 would be negative x squared, or negative 1x squared, but we don't need the 1. So this time, when we're combining like terms, my highest power that I see is this negative 3x to the third. I can combine my 6x squared minus my 1x squared. And 6x squared take away 1x squared would be a positive 5x squared. And then I've got this plus 2x that I can put down. So there's my multiplication. So this one's asking us to divide these. So we've got 2x minus x squared over 3x plus 1. And we could pull an x out of this and see if it would simplify, but there's not really anything I'm going to be able to do with this. These terms are not the same. They're not going to cancel out, so we're pretty much done with that one. Okay, so example 2 says for f of x equals negative x plus 4 and g of x equals x squared plus 2, let's add them. Okay, so I'm going to let this one be my blue. And again, I'm going to let this be my green, the x squared. And it's telling me to add them. So we're going to want to say negative x plus 4. And then we want to add, so put our plus sign in here. And remember, we don't really need parentheses if we're adding. It's not going to change anything. If you want to put them there, that's fine. But when you need them is when you're subtracting. Okay, you're going to combine like terms if there's any like terms to combine. It looks like the highest power I have is an x squared, and I have one of those, so I've got x squared. I've got a negative x, and then this plus 4 and plus 2 could go together and get me plus 6. Okay, this time they're telling me to subtract and to, in the end, plug in a negative 5 for x. Okay, so when I work this problem, I can do, let's keep this the same. So we've got blue is our f of x, green is our g of x. So we are subtracting this time. So we're going to say negative 14x plus 9. Then it's asking me to subtract, so I'm going to use my minus sign. And I'm going to use my parentheses because I want to make sure I'm subtracting this whole g of x, which ended up being x squared plus 16. Now it's okay to go ahead and put your minus 5 in for your x right now, but I would go ahead and simplify this down if I were you. This negative needs to go to both things. So negative x squared minus 16. I could write this as negative x squared minus 14x. I took care of this term and this term, and I could put my 9 and my negative 16 together to get me a negative 5. Okay. Then you're supposed to go and plug that in. So we've got negative. So everywhere I see a x, I'm going to put parentheses because they say plug in a 5, negative 5 for that. So negative 5, negative 5 times negative 5 is 25, but we've got this minus out here, so negative 25. Negative 14 times 5 is going to be positive. 14 times 5 70 minus 5. So negative 25 plus 70 minus 5 is going to get me 40. Okay. So I'm going to work this one just a little bit different and show you how to do this on the graphing calculator. If this is my problem and I'm wanting to subtract these, I could rewrite this as f of negative 1 minus g of negative 1. But we know what we're doing is we're taking our f of x, which is 4 minus x squared, and we're subtracting our g of x, which is 2x. So in the end, what I'm doing is saying I want to plug in negative 1 for x, and then I should get my answer. So I'm going to go to the graphing calculator real quick, and I'm going to type this in just like it is with the parentheses and everything. So 4 minus x squared minus parentheses 2x. So go to y equals, we've got 4 minus x squared, and then it's minus, and we have parentheses 2x, and then close those parentheses. Now remember that what we were looking for is what happens when we plug in a negative 1. And so I can get that if I hit second graph and I look for negative 1, the answer should be 5. Okay, so let's just check that. So we think that the answer is 5. So 4 minus, instead of x squared, I'm going to put negative 1 minus 2 times negative 1. Okay, so I would have 4 minus minus is a plus. Negative 2 minus 1, that's going to end up being plus 2, which is not 5. So 4, oh, I forgot to put the squared. So 4 minus negative 1, let me erase that because that's going to make this mess different. Negative 1 times negative 1 is going to end up being positive 1. And then we've got a minus, so that's going to make it be negative 1. So 4 minus 1 is 3 plus 2. It does get us our 5. Okay, so you can work these problems on your calculator. And this one, since you can work the ones you have a number there for, but since this is an A, we can't work this one on the calculator. So they're saying take x plus 5 and multiply it by 2x plus 3. Okay, so you're going to use FOIL. So first term times the first term. So x times 2x would be 2x squared. Outer terms, x times 3, so plus 3x. Inner terms, 5 times 2x would be plus 10x. And then the last terms, 5 times 3 is plus 15. So if we reduce that, we've got 2x squared plus 3x plus, we can combine that 3x and that 10x. And these two can go together, and that's going to be 13x plus 15. Now they want me to plug, instead of x, they want it to be an A. So our final answer, wherever we see an x, we would want to put the A there to get the right answer. Okay, this time we're subtracting again. We could use our calculator on this one because we're plugging in a number. So we're saying x squared minus 2x. They're asking us to subtract. So minus, make sure when you are subtracting you put it in parentheses. If we don't use our calculator, we would just do this, distribute that negative. And we're going to get negative x here when we distribute that negative to the x, and then negative 3 when we distribute that negative to the 3. We could combine these two things. So that would be x squared. Negative 2x minus an x would be negative 3x minus 3. Well, the last step is asking us to plug in the negative 1 wherever we see an x. So I'm going to leave my x's blank, and I'm going to put in a negative 1 wherever I had those. And that should give me my answer. So negative 1 squared is 1. Negative 3 times negative 1 is positive 3. So we would end up with 1 plus 3 minus 3. So we should just get 1. Now if we go to our calculator and we type in this very first thing, x squared, go here. So I'm going to y equals, I'm going to clear this out. I want to raise this up just a little bit so I can see. So our equation here that we had x squared minus 2x minus, so x squared minus 2x minus x plus 3. So x squared minus 2x minus, in parentheses, x, was it plus 3? Plus 3. Okay, and then I go to second graph. I want to know what negative 1 is, and if you look right across, it's 1. And I just think this is a really good tool to make sure that you are checking yourself. That was supposed to be the answer. So we know now that we've got it right because we've got two things that are matching up. So for a pair of functions f and g, determine the domain when you add, subtract, multiply, and divide them. Okay, so we talked about already that we really only have a problem right now if we have a division. So if we have anything on the bottom of the fraction, it can't be equal to 0. So if this is our function, we've been using blue for f of x, and we've been using green for g of x. And they ask us to look at what happens if we add, find the domains, if we add them, we subtract them, and we multiply and divide them. Okay? Well, if we add these two together, the domain of f is going to have a problem, because if we just look at the domain of this function f of x, it's going to have a problem because we have a fraction. So right here, where x minus 4 is equal to 0, when we solve this by adding 4 to both sides, we're going to get 4 here. So the domain of f is all x's, such that x is a real number and x is not equal to 4. Now the domain of g is just all real numbers because it doesn't have a fraction or anything. So if it's when we're looking at addition and subtraction and multiplication, if it's a problem for one of these, it's going to be a problem for both. So you want to go with the most restrictive of the domain of f is all x's, such that x is a real number and x is not equal to 4. Okay, it looks like on this one, f of x, 2x to the third, it doesn't have any problem because it's not a fraction. This is going to have some problems where x plus 3 is equal to 0. So we would subtract 3, and we would say x is negative 3. So the domain of g is all x's such that x is real and x is not equal to negative 3. Remember that we're not talking about division right now, but if you're adding or subtracting or multiplying, if it's a problem for one, it's a problem for both of them. So you're going to put the most restrictive definition. Okay, so when we look at f, x squared minus 1, that's going to be, the domain is going to be all real numbers. We don't have a fraction. This one has, we can't let x equal 0 on g, so the domain would be all x's such that x is real and x is not equal to 0. So if we want to list the domain for adding, subtracting, or multiplying, we have to list the most restrictive of the two. Okay, so how do we define the domains of f divided by g? We want to find the domain of f and find any values of x for which g of x is equal to 0. The domain of f divided by g is the set of all values common to the domains of f and g, excluding any values of x found in step 2. Okay, so the domain of f here, don't have any problems there. It's just all real numbers. The domain of g, 6 minus x, that's not a fraction either, so that's going to be all real numbers. So when is g of x, which is going to be the number on the bottom, equal to 0? So 6 minus x, when is that equal to 0? We would subtract 6 from both sides, and we would get negative x is equal to negative 6. Then to get rid of this negative, we're going to need to multiply everything by negative 1. So that's going to be x is equal to 6. So this is our problem. Okay, so find any values of x for which g of x is equal to 0. And then the domain of f and g excludes any values of x found in step 2. So it's all x's such that x is a real number and x is not equal to 6, because if it's equal to 6, it's going to make it all turn into 0. So on this one, the domain of f of x, it's all real numbers, it's not a fraction. The domain of g is again all real numbers. We need to find out when g of x is equal to 0. So 6 minus 2x, when is that equal to 0? Subtract 6. So negative 2x is equal to negative 6. Divide by negative 2. So x is equal to 3. That's our problem. So the domain is all x's such that x is real and x is not equal to 3. Okay. And that is the end of section 4 in chapter 2.